It's reality. First ever warp bubble has finally been created. Jumping from star system to star system with the push of a spacecraft's warm drive thrush is a Star Trek-inspired futuristic technology that has little in common with today's space travel. Not only would new technology be required to achieve this sci-fi future, but it would also necessitate breaking one of nature's most fundamental laws, the speed of light. It's a long shot, but there's a ray of optimism on the horizon. Today we'll shed light on the first ever warp bubble that has finally been created. Now, after hearing this, many of you may be wondering if this is really true or just a false claim. And even if this is true, how soon will we be to be able to travel using this technology? Well, stick around as we dive into the depths of the warp bubble and the impacts it'll have on future space travel. So let's begin the video. The capacity to travel faster than light, known as warp drive, is purely fictional. At least such was the case until now. According to the newest report, the world's first warp bubble was discovered by mistake by DARPA-funded researchers. The Limitless Space Institute team, directed by Dr. Harold G. Sonny White, a former NASA warp drive expert, has discovered an interesting encounter that the spaceship could leverage for speedier travel. White and his team claim to have established the necessary circumstances to, theoretically, produce a small warp bubble in a lab in a recent report published in the European Physical Journal. While White and colleagues have tested some of the science underlying this discovery in the lab, the warp bubble itself is still simply a theory based on computations, which White and colleagues have yet to prove empirically. However, if they succeed, White believes it'll dramatically transform the science of warp speed space travel. This has not been done before in the literature and hence is significant, White stated in its statement. It's a matter of precedence for the idea of a space warp analogous to the Chicago pile for nuclear reactors. To be clear, our finding is not a warp bubble analog. It is a real, albeit humble and tiny warp bubble, said White, dismissing any suggestion that this is anything other than the construction of a real-world warp bubble, hence the significance. The discovery happened during a research endeavor that wasn't looking into warp drive, or mathematical Miguel Alcubierre's theories from 1994, which were the first to hint at what warp technology could be like. Rather, it happened as part of a research initiative looking into Casimir cavities and their propensity to generate energy. It took an engineer undertaking the research at the exact right time, one who was knowledgeable with warp technology research and knew what he was looking at, to notice that this completely unrelated research had produced a warp bubble, thanks to an extremely fortunate coincidence. The observed result was not analogous to a warp bubble, but rather a very small, very simple, true-to-life structure that completely matched Alcubierre's findings. We now know that physical equipment will be required to produce a true warp bubble for the first time. This indicates that warp field theory has progressed from a far-fetched science fiction concept to something that can be built in the real world with existing tools and technology. Let's take a step back to grasp what a warp drive is before we get any further into what this warp bubble could represent for space travel. The secret resides in two of Einstein's seminal publications on special and general relativity, published in 1905 and 1915, respectively. These publications established three fundamental physics hypotheses, among other things. 1. The speed limit of the cosmos is the speed at which light travels, 299,792,458 meters per second. 2. The flow of time will shift relative to an observer at speeds nearing the speed of light. In other words, space travelers who travel quicker age slower than their slower counterparts, as seen in the movie Interstellar when they visit the planet of the water world. 3. Space and time are linked together in a fabric that ebbs, flows, and bends around mass, dubbed space-time. Gravity is the cause of this curvature. White explains that space warp is one of two loopholes discovered in the theory of general relativity by theoretical physicist Miguel Alcubierre in a 1994 study. Warping space-time could resemble the fabric bunching up in front of the bubble and then stretching out behind it in a train, similar to a wormhole, which potentially allows you to skip across space-time by walking through a region where the fabric is folded together like a fan. Alcubierre compares the phenomenon to being on a moving walkway at an airport in a presentation from 2017. You can imagine that the floor behind you is being created out of nothing, and in front of you it's being destroyed, so you move along. A warp bubble could move along this walkway and ride the bunching space-time fabric in such a way that its relative time remains slow while moving great distances faster than the speed of light, according to theory in science fiction. The majority of people are familiar with the notion of warp drive because of Star Trek. Our spaceships are currently constrained by Einstein's laws of physics. You must hurl something in the opposite direction as the one you intend to travel to speed your spacecraft. This has meant burning fuel and shooting it out the back of the ship in a violent physical reaction throughout the history of aviation and aeronautics. The drawback of this method is that you eventually run out of things to toss. The other limitation is that your ship is still subject to Einstein's equation describing special relativity, which states that as you get closer to the speed of light, more and more of the energy you expend goes into increasing your mass, until you reach a point where no amount of additional energy can get you any faster, and you never quite reach the speed of light. It's impossible to accelerate faster than light using ordinary physics, since the more energy you put in, the bigger your ship becomes until you can't do anything else with it. Finally, there's another catch. The warp bubble must be encased in negative energy, such as that produced by anti-gravity. Unfortunately, that isn't something that can be easily replicated in a laboratory. So, are you guys having a good time watching the video? How does one overcome these challenges to make space travel through the warp drive a reality? Let us give you a hint. The answer lies in a phenomenon we've discussed earlier in the video. So while you rack your brains over this, do subscribe to our channel and click on the bell icon to receive instant notification about all our future videos. The negative energy limitation may appear to be a death ring for warp drive, yet there are still some rays of hope. For one thing, according to 2021 research by physicist Eric Lenz, who studied the problem during the lockdown, we may be able to do away with it entirely. The Casimir phenomenon, which causes magnetic fields to fluctuate, could be the source of the solution for White and colleagues. In a nutshell, the Casimir effect is the attractive force of fluctuating magnetic fields that holds two objects together in a vacuum, such as plates or mirrors. The detailed numerical analysis of our custom Casimir cavities helped us identify a real and manufacturable nanomicrostructure that's predicted to generate a negative vacuum energy density, such that it would manifest a real nanoscale warp bubble, however humble it may be, White says. A toy model consisting of a 1 micron diameter sphere centrally located in a 4 micron diameter cylinder might be used to investigate the Casimir effect energy density experimentally, according to White and colleagues. The DARPA warp bubble appears to have the potential to be genuine, if it can be experimentally validated. Not all scientists, though, are convinced. Regardless of how this recent discovery turns out, White believes that scientists and aerospace engineers are still a long way from constructing a true warp drive, but the future looks bright for space travel. So, do you believe you'll be able to see humans jump from one planet to another in an instant within your lifetime? Or are we still hundreds of years away from this? Let us know in the comments below. And if you want to watch more of our amazing videos, then stay tuned.